In order for a computer in Des Moines, Idaho to send a network packet to a computer in Detroit, it would have to use its own source address along with a destination address of where it was sending it to. It would broadcast an analog signal across nodes until it found its destination over telephone lines in the US. The hardware and telecommunications have evolved, but two basic principles we still use today. You need an IP address and a way to forward these packets. The telecommunication community was growing at an alarming rate. By the early 90s, the internet became flooded with IP addresses, and there were companies out there trying to connect their entire company digitally. There were hundreds, if not thousands, of computers on public networks. All you needed was a range of IP addresses, and you could create many smaller networks within one giant network. This was back in the day when everyone was on a public classful address. The addresses were dwindling fast, and by 1993, the Internet Engineering Task Force came up with classless addressing. In essence, all you needed was one public IP address with a list of private addresses that existed off the internet. You could use certain ranges just like a classful range of addresses internally. It could be broken up into tiny little subnetworks across the hall or across the country, but as long as these addresses hid behind the router, they could theoretically have as many computers on one network or many networks that they needed. Private addresses had specific ranges for each class. The ranges went as followed. You had a Class A license that started with the network ID of 10.0.0.0 with a network mask of 255.0.0.0 with 126 number of networks that could host over 16 million network hosts. That is a lot. In Class B, you could have 172.16.0.0 all the way up to 172.31.0.0. The subnet mask, of course, would be 255.255.0.0, and the number of networks would be over 16,000 networks with 65,000 hosts to each network. And then, of course, you had Class C, which is 192.168.0.0 to 192.168.255.255. Most of the time, that's what we're used to with our home routers. Then you have 255.255.255.0 for the subnet mask, and you could have a total of 2,000 separate networks with 250 hosts per network. Generally, you'll be working with these size private LANs most of the time. We will get into what a network mask is, so don't worry about that at this point. We'll definitely go through that. Just know that these are what the addresses look like. Anyone can use these addresses as long as it is not used on the internet. If these were to be exposed to the internet, the network packet would just be stripped away of these addresses and the network packet would be dropped and disappear forever. From now on, when dealing with most local area networks, you will be dealing with private IP addresses on the network. This is what has sustained IPv4 for the past 25 years. It's called subnetting and has kept it in the game. The best way to understand a private network is to see how it works on a LAN. It is the most common type of network in the home or business. As I said before in the previous video, a LAN is a collection of devices in a small area such as a home or an office. Each device shares the same network address while having its own address that allows it to communicate within the network. The network address and the host address will be combined into one address. A good way to think about a local area network is to compare it to a neighborhood. A neighborhood has a street and house numbers that identifies its location. This way we can call the network address number the street name and the house number the host address. So 10.10.11.0 would be your street address, and 10.10.11.15 would be your house address. Dot 16 would be another house address, 17 and 18. These are your host address on the network, and the network ID would be 10.10.11.0. Okay, let's say you're trying to deliver a message from one device to another device on the same LAN or local area network. When a device needs to send data to another device, it creates a network packet. In this packet of data, it includes a source address and a destination address that can be read by other devices, such as a router. A subnet mask tells where the network address ends and where your host begins. This is an example of a private Class A host address. A subnet mask on the computer uses a calculation in binary to resolve your network ID by knowing where the zero begins. We will go over that process in another video. So once your subnet mask can determine if your destination address belongs to your network or if it belongs to another LAN, it sends the packet to the correct destination. In this instance, it belongs to the same network. Let's see how a message is delivered on a LAN. When a device needs to send data to another device, it creates a network packet. The packet of data includes a source address and a destination address. It is sent to the default gateway for delivery of the network packet. The default gateway is another term for the router. As the data packet is forwarded to the gateway, the router uses the subnet mask to check to see if the network address matches the network that these host devices are connected to. This ensures that the packet makes it to the right destination. In other words, the subnet mask makes it possible to tell the router if that is the right street address and home address to deliver the package to. However, if the network address does not match the network ID at the default gateway, the network address is sent to the next router until it finds the correct address the packet is assigned to. Now to sum all this up, I want you to think of this a little chunk at a time here. All right. In order for a host device to be able to communicate on a network, it must have a host address. All right. It also needs a subnet mask and a default gateway, which all share a single network address. The default gateway is able to use the subnet mask to determine if the host address and the network packets belong on its network. The subnet mask is also entered into each networked host device to be able to know that the network belongs to it as well. So for review, classless addresses are used separately from the internet. IPv4 addresses have 4 octets divided by 3 decimals. In binary, an IPv address is 32 bits long. IPv4 supports 4 billion addresses. A network address is like a street address, and a host address is like a house number. In order for computers to communicate on a network, you must configure each host device with an IP address, a subnet mask, and a default gateway. A network address cannot have the numbers 255 in it. Stay tuned for the next lesson where we'll go more into the subnet mask and how it actually finds the network ID.